You wake up, you look out the window, the sun is there, right where it always is, doing exactly what it always does. Now imagine it isn't. Imagine you look up and instead of a star, instead of that warm, slightly annoying ball of light that has been there every single morning of your life, there is nothing. A perfect circle of darkness cut into the sky like a hole in reality. And around that darkness, a ring of light bending inward, spiraling, like the universe itself is being slowly swallowed from the inside. That is not a nightmare. That is a black hole. And specifically, it is A0620-00, the closest known black hole to Earth, sitting about 3,300 light-years away in the constellation Monoceros. It has a mass roughly 6 times that of the Sun. And yet, if we swapped it with the Sun, you would be dead before you finished reading this sentence. Let me show you exactly how, and exactly why, and exactly when each part of you stops working.
The first thing to get right about this scenario is the gravity, because almost everyone gets it wrong. A0620-00 has a mass of roughly 6 times the Sun. The Sun has a mass of roughly 1 solar mass. If you swap them, Earth's orbital path would not immediately collapse because gravity does not care what shape the mass is. It only cares about how much mass there is and how far away it is. A black hole of 6 solar masses sitting at 1 AU from Earth, the same distance the Sun currently occupies, would actually pull harder than the Sun does by a factor of 6. Earth's orbit would not disappear, it would tighten. The year would get shorter, but the planet would not immediately spiral inward and get swallowed.
That is the counterintuitive part. The black hole does not eat you with its gravity alone, not right away. What kills you is everything else. The Sun does 2 things for Earth that have nothing to do with its gravitational pull. It provides light, and it provides heat. Remove the Sun and replace it with a black hole, even a black hole of equal mass, and you have replaced the thing that keeps the surface temperature at an average of 15 degrees Celsius with an object that emits, at most, a faint trickle of Hawking radiation so cold it is functionally indistinguishable from nothing.
The moment the swap happens, the light goes out. Not dims, not fades, goes out instantaneously. The sky does not gradually darken the way it does at sunset, where the atmosphere scatters remaining light into warm colors. In this scenario, the photon source is simply gone. The last light the Sun emitted takes 8 minutes to reach Earth, because that is how long it takes light to travel 150 million kilometers. For 8 minutes after the swap, you are still receiving photons that the Sun produced before it was replaced. The sky looks normal. The day continues. Then, at the 8-minute mark, those photons stop arriving, all at once. The sky does not turn to night, it turns to something darker than night, because night still has the moon, the stars, the diffuse glow of the Milky Way. This is different. This is day and then nothing in the span of a single second. And that is just the beginning.
Within about a week, the average surface temperature of Earth drops below freezing globally. This is not a prediction. It is a calculation. The planet's atmosphere retains heat. It is, in effect, a greenhouse, even without the Sun, holding in the residual warmth stored in the oceans, the land, the lower atmosphere. But that heat dissipates. There is no new input coming in. Physics does not allow the planet to stay warm on its own indefinitely. Within a year, the surface temperature stabilizes somewhere around -60 degrees Celsius. The oceans do not freeze solid immediately. The upper layers freeze first, and the ice insulates the water below. But eventually, with no heat input from any stellar source, even the deep oceans begin to solidify from the surface down. The process takes decades for the deepest parts. The first year kills the surface. The next few decades kill the rest. Plants die within days. Without photosynthesis, the base of almost every food chain on Earth collapses. Herbivores starve within weeks to months. Carnivores follow.
Here is the part that is genuinely strange, though. Some things survive. Deep-sea hydrothermal vents, cracks in the ocean floor where geothermal heat escapes from the planet's interior, are completely independent of solar energy. They have their own ecosystem, built on chemosynthesis instead of photosynthesis, running on the heat from radioactive decay inside the Earth's core. That heat will not disappear. Radioactive decay does not care whether there is a star nearby. Certain bacteria, certain archaea, certain extremophile organisms living kilometers beneath the ice-covered surface could, in principle, continue indefinitely. Earth, frozen, dark, orbiting a black hole in a tighter path than it once took around the sun, would not be lifeless. It would just be a world where life had retreated to the only warm place left, the rock itself. But the black hole is not done with us yet.
Here is what changes the story completely. A062-00 is not an isolated black hole. In its real location in space, it is a binary system. It has a companion star, a K-type orange dwarf, and the black hole actively feeds on material stripped from that companion. It has an accretion disk. And accretion disks are not dark. They are some of the brightest, most violent objects in the known universe. An accretion disk forms when a black hole pulls in material that does not fall straight in. Angular momentum prevents a direct plunge. The gas and dust and plasma spiral inward instead, forming a rotating disk that can extend for millions of kilometers. As material falls inward, it compresses. Compression generates heat. Heat generates light. An active accretion disk around a stellar mass black hole like A062-00 can reach temperatures of tens of millions of degrees Celsius in its innermost regions. At those temperatures, the disk does not emit visible light. It emits X-rays.
In our swap scenario, the black hole arrives with no companion star to feed from, but it does not arrive in empty space. It arrives in a solar system full of material, the solar wind particles, the interplanetary dust, the outer reaches of cometary tails. Initially, this is not enough to form a significant accretion disk. The black hole sits dark and cold, consuming almost nothing, emitting almost nothing. But this is where the timeline gets complicated in a way most people do not expect. Over thousands of years, the black hole's gravity reaches further into the solar system. The Oort cloud, the vast, distant shell of icy bodies at the outermost edge of the solar system, extending nearly a quarter of the way to the nearest star, begins to be disrupted. The gravitational landscape has changed. Objects that were previously in stable orbits over billions of years begin to drift inward. Not all at once, slowly, over millennia.
As that material spirals inward toward the black hole, it begins to form a disk, small at first. Then, over tens of thousands of years, it grows. And as it grows, it starts to produce radiation, X-rays, ultraviolet light. In the far future, an observer orbiting the black hole where Earth once was would not be in total darkness. They would be bathed in hard radiation from a growing disk surrounding an object that used to be the gravitational anchor of their world. The irony is precise. The black hole eventually produces light, just not the kind anything biological can use. The Earth, frozen and orbiting in the dark, would eventually find itself irradiated by a source that emits energy in wavelengths that penetrate to the surface, strip the remaining atmosphere, and sterilize even the deep rock. And we haven't even talked about what happens to the rest of the solar system.
The black hole is 6 solar masses. The sun was 1 solar mass. The orbital dynamics of the entire solar system just changed by a factor of 6. Every planet that was gravitationally stable around 1 solar mass is now gravitationally unstable around 6. The orbital periods change. The resonances between planets, the subtle gravitational handshakes that keep Jupiter's moons in their dance, that keep the asteroid belt from collapsing, that keep Neptune and Pluto from ever colliding despite crossing orbital paths. All of those resonances are calibrated for one specific mass at the center. Change that mass by a factor of 6, and the resonances break. Jupiter, the largest planet in the solar system, now orbits with a period of roughly 4.3 years instead of 11.86. It moves faster. Its gravitational influence on the inner solar system changes. The asteroid belt between Mars and Jupiter, which Jupiter's gravity normally keeps mostly contained, begins to destabilize. Asteroids that have been in stable orbits for billions of years start migrating. Many go inward. Mars and Earth, still orbiting, still dark, still frozen, begin to experience an increase in impact rate. On longer timescales, millions of years, the orbital architecture of the solar system dissolves entirely. Planets are not ejected immediately. Orbital instability in a gravitational system takes time to propagate. But the outcome of a system where the central mass has been multiplied by 6 and then further perturbed by the slow gravitational restructuring of every major body in the system is not equilibrium. It is eventual chaos. Planets migrate. Some get ejected.
Some fall inward. The solar system that formed over 4.6 billion years of careful gravitational sculpting unravels over the next few 100 million years into something unrecognizable, a collection of frozen, irradiated, scattered worlds orbiting a black hole that never asked to be here and will never notice the damage it has done. The black hole itself, for its part, simply continues. It does not accelerate this. It does not try. It does not have intentions. It is just mass, warping space-time, doing what mass does. The solar system was not built to contain it, and it was not built to belong here. And that mismatch, playing out over geological time, is enough.
Here is what the swap actually teaches us when you strip away the spectacle. The sun is not just a source of light. It is a gravitational anchor of exactly the right mass, positioned at exactly the right distance, burning at exactly the right temperature, with exactly the right stellar output. Change any one of those variables significantly, and the conditions that produced 4 billion years of biological evolution on this planet stop existing. The closest known black hole is 3,300 light-years away. That sounds enormous, and it is enormous by any human measurement. But in the context of a galaxy 100,000 light-years across, it is local. It is practically a neighbor. And A0620-00 is just the closest one we know about. The Milky Way is estimated to contain somewhere between 100 million and 1 billion stellar mass black holes, the collapsed remnants of massive stars that burned out over the galaxy's history. Most are invisible. Most are isolated. Most are wandering.
We have never detected one passing through the solar system. We have no evidence that one is heading this way. The orbital math, for now, is stable. But A0620-00 is out there, 3,300 light-years away, orbiting its companion star, slowly consuming it, moving through the galaxy on a trajectory we have been able to model for only a few decades of observation. It is not coming for us. Probably. But the universe did not build a fence around your solar system, and the closest black hole has had a very long time to change direction. Sleep well.